Ja lubię tę atmosferę. Powiem wam, że tęskniłem za takimi właśnie spotkaniami on-site, żeby nabrać tego takiego zwykłej ludzkiej bliskości. Także słuchajcie, no to co? No to witamy na AWS User Groupie. Nie wiem, które to już jest spotkanie. Matko Boska.
50, któreś? 57.
O Boże, 57, to prawie jak mój wiek. Słuchajcie, witamy was na tym spotkaniu. Ponownie jak z Filipem Morrisem je organizujemy, w tym jakże wykwintnym miejscu jak Hevre. Właśnie słyszycie lód w tle, więc możecie sobie wyobrazić tylko dla tych, którzy są z nami online, jak jest tu nam przyjemnie. Następnym razem zapraszamy, ale dzięki temu, że zorganizowaliśmy to w formie hybrydowej, każdy mógł wybrać swoją, że tak powiem, swój komfort, nie?
Jak najbardziej.
No bo istotne jest to, żeby w dzisiejszych czasach każdy mógł uczestniczyć, żebyśmy mogli dzielić się wiedzą jako grupa AWS-owa. No i każdy to robić mógł tak, jak lubi. Ja nazywam się Maciej Lelusz, prowadzę tą grupę od, nie wiem, już chyba 6 lat. Szymon.
Ja nazywam się Szymon Kędzierski i jestem chyba prowadzę ją już jakiegoś roku, może.
Nie, no co ty już za 2 lata? Nie, wiesz co, to pandemia, wszystkie lata się mnożą razy 3. Większy deal. Słuchajcie, dzisiaj, no myślę, że przede wszystkim będzie się trochę działo. Dla aktywnych na miejscu mamy te 3 oto piękne, wypełnione różnymi ciekawymi rzeczami.
Warto, ja widziałem coś w środku, warto.
Ja też już widzę i powiem szczerze, nawet fajnie to wygląda, słuchajcie, więc na najbardziej aktywnych na miejscu takie torebeczki. Oczywiście nie zapominamy o was, którzy są online. Również jedna z nich będzie dostępna.
Maybe we'll switch to English now.
Oh, shit, I forgot.
It will be easier for everyone.
Yeah, let's touch it. Blue screen. We don't want to have a blue screen. Guys, so welcome everybody in another Krakow meeting.
Yes, welcome everyone.
Good. So what we have right now? So the 2 packages for people who will be the most active here, and 1 package for somebody there in the void. So
Online. Yeah,
Good.
and it's really worth it. So it's really worth to be active because I've seen what is inside, and yeah, it's really interesting one.
I get epic. So guys, there is another thing. Also, we have a pool, and on this pool, we'll give you a $50 vouchers. There are going to be questions regarding our sessions today. Not easy one, so go for it. The link will be on our YouTube channel. And hopefully we'll show them time to time here if we don't have a blue screen, which is blue screen is normal. You know, it's April. It's April, man. You're not supposed to have a blue screen. Yeah, good. That's
perfect.
Perfectly. So another AWS meeting. My name is Maciej Lelusz. I'm AWS hero, organizer of these meetings for, I don't know, 6 years. And Szymon here.
Yes, my name is Szymon Kędzierski, as I mentioned, and Maciek corrected me. 2 and 2 more, maybe 3 years, helping organizing this meetup.
And today we are here because of the help and support of our everlasting partner here in Krakow, so Philip Morris. And the first session, they will talk about how to migrate 500 apps. I think it's another easy one. Is it an easy one? You think, Shimon? Yeah,
definitely not.
Like this, you know. Come on, 500 apps.
Well, we'll see. We'll see.
And I think what we should provide the voice right now to you, my dear friend. Yeah, perfectly. So, Piotr, could you?
The stage is yours.
The stage is yours.
Hello. Thank you very much, guys. Let me just switch on the logistics. All right. Screen. This one very well. And I guess we all see the screen, correct? Very good. Okay, hello guys. Oh no, we don't. Now we do. Okay. So hello and welcome. Welcome to the guys that are here in Hevre today, and welcome to people that are watching the stream, and then later they can also watch the YouTube movie. I would like to today tell you about the story of PMI, where we migrated 500 applications to the cloud, and how we did it exactly, why we had to do it. My name is Piotr Kondratowicz. I am solution manager working for PMI IT Hub for 8 years. Sorry for that. Yeah, okay, great. I'm again visible. I'm working for 8 years in PMI. Before that, I have been working in other consulting companies. In PMI, I am currently managing a group of engineers, architects. Before that, I have been a solution architect, analyst, and other roles that I had. Now, what is PMI if you don't know it? PMI is Philip Morris International. We are a tobacco company, FMCG market. We are a global company. We are in 180 countries, and we do employ over 70,000 people around the world. So it's global. Now, today I'm going to tell you something about what we did in PMI, so some sort of bits and pieces of history, why we are there. Also, sorry for that. Yeah. Also, why did we pick the public cloud? Why we went that direction? I am going to tell you something about the theory of cloud migration as such. What are the approaches? What are the steps that you have to follow? Later, I'm going to show you the migration program that we created, how we shaped it, and how did we create the teams, and how does it work together. Some sort of migration phases that each and every application is going through, and our recommendations. So the mistakes that we have made, and if you are still before that, maybe you wouldn't make them, okay? So that's it. If we have time, of course, and you will have some questions, I will be more than happy to answer any of them. And that's it. Now, let me start from the great motto, because every super presentation always starts from the motto, right? So we have to do it professionally. And the motto that we have, but please do not try to look for it in pmi.com page, because this is unofficial, is that crappy application just moved to the cloud is still a crappy application, all right? This is something that is very real and very true. If you ask why, because it costs money. If you do not transform your application into more cloud native, it will cost you a lot of effort, a lot of maintenance, a lot of stress, right? So that's the motto. We are through. Now, prologue. As I said, we are a global company. So even in Krakow, we do employ over 300 people in IT departments. Those guys are creating new applications. They are maintaining existing applications. And throughout the years, we have been creating applications. So we ended up in having lots of them. I will show you later how many, if I'm allowed. All right. Generally, the issue that we had was that we did not have any idea how many of applications do we have, what they are doing, where they are hosted, who does what, where does it integrate to. This was the problem that we're having. Okay. Now, what else happened in the meantime? Sorry for that. We as PMI launched a new product. This was heat not burn technology, maybe you had it, it's IQOS. Generally, the thing is that with the product launch, it wasn't just a product. It was the whole change of how do we engage our customers. Instead of, previously, we're just buying the raw material, we're producing the product, we're selling into the whole market, huge companies that were just distributing it, right? This was our job. But now it changed into engaging the customers directly. Now we have started to set up web pages where the customer can just go there and order the product. He or she can also dispatch the goods directly to them. We also started to provide electronic appliance, something that we have never done before. So with that, we had to change the mindset of PMI, also change of mindset of IT, and we called it transformation of PMI. Okay, cool. One thing that also happened, and this was very, let's say, a breakthrough for us, we started to invest in private cloud. Why? Because previously, when you started the new project, you had to request for the hosting for the hardware, basically. So you were making a request, 20 people had to approve it, and after a few months or weeks, you got your hardware. Then, of course, RAM was missing or hard drive was missing. Then you were waiting additional couple of weeks, and then after I know many weeks, you finally got your server, and you could start working on that. So we wanted to change it, and we set up something that was called private cloud, software-defined infrastructure in PMI terms. It was pretty cool because the tech stack was based on OpenShift and something from VMware. Generally, it changed our mindset into, if you wanted a server, you just did a few clicks, like now you can do it on AWS or Azure, and here you had the server, right? This was really a breakthrough for us. People started to use it. People started to deploy stuff to it. Great. And then what happened? We got a new CTO, right? And the guy started to ask very good questions, like, is really PMI into hosting business? Are we really the best on the market when it comes down to hosting? Of course, we are not. We are producing tobacco stuff, right? So instead of maybe focusing on creating our own private clouds, maybe let's use companies that do it better, right? And as the guy was actually calling all the shots and sponsoring all the things, so we went there. So public cloud it is. All right. Now, we have many public cloud providers on the market where we started to look into all of them. Sorry again. Okay. We started to look into all of them. We started to talk with, I think, 3 biggest one. They started to bid. We did some kind of exercises with all of them. And surprise, surprise, we picked AWS. Okay? That was super surprise for you. Now, what we did apart from that, we created something that is called Deep, because we didn't want it just to give people an account in AWS. This would be nice, but we wanted to give people the whole package. By whole package, I mean something that would allow them to start their own products and have already all the things that they may require out of the box. So Deep was actually providing that. This was something that was really speeding us up during projects implementations. So you as a product owner, you have this kind of a view, portal. Also as a development team member, you have that one. You see all your products in here. You can create a new product or request creation of new product. You can contact security. You can contact support. You can do many things. And if you go into specific products, in one single view, you have access to, you have access to, yes, you have access to all the services that are behind it. So we picked Jenkins, CloudBees distribution actually. We picked Jenkins for CI/CD. We picked Atlassian Suite for Jira, Bitbucket, and Confluence. We picked Artifactory JFrog for artifact storage. So in one single place, you had access to all of those services, and they were already integrated for you. You don't need to do any integration yourself. About integration, we picked MuleSoft in order to have enterprise integration solution in place. This is what we did. Apart from that, as I was telling you, we had, let's say, not sorted out situation with applications, right? We knew that we had many of them. We had many data sources of that. So something had to be done about this one. So what we did, we set up a dedicated team that was actually looking into all the applications that we have in different data sources. They were discussing different, they had many discussions with application owners, with support teams, with people that were actually calling the shots. And then they did the count. And actually, I know it's a big dashboard, but what is important for us are those 2 numbers, right? So we ended up in having almost more than 2,000 applications. This is huge. Even for a company like ours, this was too much. We benchmarked it against other companies like us, and this was much too many. So we started to plan decommissioning of those applications. This is actually the best what you can do with having that kind of an issue. You should start thinking which applications are really needed, which one of them you don't need, right? So some of them we classified as to be decommissioned. Some of them we classified as to be consolidated. Consolidated means merged together. The very good example for that is that in different affiliates, different countries that PMI is operating, we do have same applications. For example, car fleet management. All right, each country has the same application. It's just named differently, and it has different language of user interface. Right. So it's just a matter of meeting together, discussing that, okay, this application that is doing this simple stuff should work like that. And somebody in the top has to make a decision, and then we have it. So some of them were actually consolidated. Some of them, actually most of them, needed some kind of modernization. And we ended up in having more than 500 applications to be migrated to the cloud. Okay, so once we had that, we started to look into what do we actually have in our applications. And we found out nasty surprises. Some of them were that we had issues we had issues with getting support for the applications. We had issues with finding right documentation. So there was no documentation, there was no knowledge in the organization. There was some, but either it was outdated or somebody left the company and nobody knew where the docs are. We could even dream about having something like automated tests. So there was no possibility that we just move the application, run the test, and see if we broke anything or not. No, we had to do it ourselves. What else? We're missing experts. We were having very poor code quality. There was a huge vendor lock-in. By that, I mean that we loved Microsoft. Okay, so IIS, .NET, and MS SQL. This is something that we really loved, and in past tense. And this would be great if we would pick Azure, but we didn't. And this was on purpose. We didn't pick Azure just because then we would afraid that we would be maybe lazy not to transform enough. But with AWS, it actually makes sense to transform your applications, modernize them, get rid of licensed software, go more into open source. So this was another problem we had. What else? We had issues with management of permissions with some of the applications. So they were not managed centrally. Of course, majority of them were, but for some of them, there was like custom user management modules. And then the guy was leaving the company, or supplier was leaving the company, but he still or she still had access to the application, right? And that was tricky. Security doesn't like it. Integration approach. Yeah, our strong preference throughout the years was exchanging flat files. Flat files are heavy, they are long, they are hard to analyze. It's not that easy to integrate with that, but this was the preferred approach throughout the ages. And outdated software. Of course, all the migration initiatives, you're dealing with old software. This is not something that was written 1 year ago, because if it would be already in the cloud, right? But no, here there was the software was outdated. We're using very legacy solutions. Some of them were really critical to fix. So we had also that problem. Then what we did, we started the learning mode. Okay, so our goal was actually not to migrate applications in the beginning. Our objective was to learn how to migrate applications. Try it out, try different approaches, and see which one is the best for which scenario. Okay, so we focused on that mode, let's say, for 12 months. Okay, throughout that time, we managed to look into 200, almost more than 200 applications. Okay, and out of one single team, we ended up in having 3 teams in different geographical locations. And within 12 months, as I was telling you, we managed to migrate. Wait for it. 10 applications. Okay? So 12 months, 10 applications. Just remember about this because it will be a question for the later. Okay, never mind. Theory. Just to let you understand what are the possibilities when you're migrating the application. This is showing you, I mean, this is based on the, let's say, rule of 6 R's. This is something like a market standard, very common in migration theory. Generally, this is explaining you what you should do or what can you do with the application. And this is a great graph in here, but generally, what you can do. First of all, you should try to retire. You should try to retire the application when you can. This is the best approach, unless the customer will shout at you, but you should try doing that. If the application is not needed, you should try retiring it. Another, let's say, approach you can do, is that you can try repurchase. Repurchase is another great approach that you should try doing. Not sure why is it, okay. Repurchase means that, okay, you have been maintaining the application on your side for 10 years, but suddenly there is some supplier on the market that does it better. They provide it to you as a SaaS service. So if they do not want some enormous amounts of money, you should go for it because it's much easier. You just sign the contract with them. You pay the license fee, but you do not need to manage the infrastructure. You do not need to manage the code itself, the changes. This is out, right? So when you can, also please try repurchasing. There are also some cases that you basically cannot touch the application. This is retain approach, okay? So in our case, it was many of the applications that are running on the factory floor, operations applications, right? You have a machine in here, and the machine is producing products very fast, right? So the server is connected to that machine, and the latency requirements between those two elements are so low that if you move that server a few thousand kilometers away from that machine, it will stop to work, okay? You will have issues with production, you will have disruption on the factory, so you don't want that. For some of the cases, you just cannot do anything, and that's it. You have to deal with that. Now, actual migration. There are three main, let's say, basic approaches here. So you can rehost. You can try to rehost. Rehost is just lift and shift, okay? You're taking the application from on-premise. You're moving this to the cloud, EC2 or whatever there is, but without much changes as it is, okay? So you can rehost. What else you can do? You can also replatform. Replatform is already changing bits and pieces, not too much. For example, you are changing the database platform that you're having your application on. You can also change the application server. Small changes, still very limited. And what you should do, actually, for applications that really matters, or they're really big, you should refactor. Refactor is rewriting the application as whole, or it is carving out some bits and pieces of the application outside of the application. So out of the monolith, you are creating some sort of smaller application plus satellites. This is also working, but still this requires much more time, much more efforts, and for sure it requires people that knows how to do that, okay? And this might be a problem. And now, why we do not do cloud native for all? Generally, the answer is pretty simple. Yes, once we have it. Okay, because it costs money. Yeah. Sorry. Okay, cool. So it costs money. If you would like to re-architect all of the applications that you have, you wouldn't do that for 2 years. You would do it for 20 years. And once you finish your migration program, whatever you migrated in the beginning would be already outdated, okay? So you need to somehow measure what is really important for you, which applications are really making a sense in order to invest in them, and which are just Mickey Mouse applications, okay? Actually, we have lots of them. There are some applications that are used by 2 guys in the company, but you have to still have it because there is a compliance need, there is some kind of requirements, you still need to have it. But maybe let's not invest too much money into those kind of applications, just invest it where it makes sense, okay? Good, so now, next part would be about the setup itself. So how did we set up the whole thing? As I was showing you, throughout 12 months, we did 10 applications, and we had 600 of them in total. So you can see clearly that it was not enough, right? The pace was not that great. So what we had to do, we had to scale up. So from team of 20 people, 15 people, we quickly scaled up into team of 150. We had to sign up with external contractor. And this allowed us really to get up to the speed that we really wanted. Apart from that, we had to set up new processes, change management stuff, cutover processes, everything around that had to be set up. We set up new team structures. I will show you later on the next slide how exactly did it look like. Apart from that, guilds. Guilds are basically, this is a nomenclature, but guilds are a group of senior guys that are defining patterns. They are defining stuff that never appeared before. So those guys were actually defining patterns and standards in order to have this kind of a factory mode. So if there was a new application, it requires some portion of technology. Those were the guys that were actually telling us how to do that. We had the architectural guild, we have DevSecOps guild, so those people are working on this one. And last but not least, we had to do fit gap analysis. As you saw, we received the platform. We received the platform. Platform was great. It had all those services out of the box, was perfect, but we're still missing a couple of things. We're missing, for example, the biggest thing that we're missing was actually domain joining. Majority of the applications that we're hosting before were using domain joining, okay? You are getting security, you're getting access to Active Directory, really out of the box, right? If you domain join. It's not perfect, but we had it. And now if we would be to get rid of it with all the applications, it would again take us ages. So we had to have that delivered. And of course, we raised the PR and we got it, okay? We got many things like that. But this was the, let's say, process of fit gap analysis. Now, the program structure. We formed squads, okay? Here, actually, they are called teams, just to simplify it, but we created squads, and those guys, those teams were focused on the business area. So as you can see, we have operations team, and those guys were doing applications that are only from the factory floor, right? We have a consumer team that were doing anything that is related to the customer, sales or distribution. We have a product team. So those guys were moving the application that are used by the research and development departments. So guys that are generally delivering our own products. And other teams were also shaped. We had also some kind of experts guilds. Those were architects, those were integration engineers, those were security guys, those were testing automation people. And of course, if we got really unlucky, we always were running like children to AWS, and they were also helping us, okay? Most of the cases. All of that is still managed with SAFe, so Scaled Agile. With each and every program like that, we had a PMO. We have a PMO. We have a program manager. We have product owners that are actually taking care of the stuff that has to be taken care of in such programs. So there are people that are taking care of the vendor management, communication, change management, governance, and this kind of stuff. So this also was happening and is happening still. And this was the rate of the count of the applications that we are migrating. So as you can see, we were warming up in the beginning, but then I can tell you that we actually are reaching those targets because more or less it's about 25 to 30 applications a month. Okay, so just imagine the situation that you would be within your team or within your project, you would be going live with 30 separate projects a month. So this is the scale, and this is how this was achieved. Okay, good. So now, migration phases. Those are the phases that we identified and we wanted to have, and this was like natural for us. So we are always starting from the design and discovery. This is the first phase for each and every application. This always starts from the application owner engagement. This is super, super important. I will tell you later why, but generally it consists of involving the person and, of course, getting whatever those guys have already about the app, right? Because this is your single point of truth. Once you have that, we are starting the research. So we are reviewing the infrastructure. We are reviewing whatever we received in that stage. And finally, we are trying to fit everything into those patterns that we already have. In case we don't have a pattern for specific solution, we have to create a new pattern. And then back to those guilds, right? We have to contact them. They are figuring out how to do this or that. And we have it. Once this is done, sorry for the blinking all the time, not sure why. Once this is done, finally we can start doing the design, all right? So all the architects does whatever they love, so they are designing, they're writing, they're drawing in all those nice tools. So people are designing how the application should run in the cloud. Also, what we are doing, we are calculating costs. I mean, in such a company, you always need to know how much are you going to spend next year, next month, whatever, right? You have to be prepared for those costs. And finally, once this is all done, it goes to the next team. And with that, we also have to do some kind of knowledge transfer to that team. And then execution starts. All right. So with execution, actually here there are in parallel happening many different activities. It's not sequential order. We are doing in parallel different activities, and one of them is scripting of the infrastructure. This really helps in order to automate things. This really helps when you need to move from dev QA to production. You're just defining the code. We are using Terraform Enterprise. We are basing on composite modules. So it's a bit like CloudFormation stacks, a bit. So we generally use composite modules. Those are reusable blocks. And yeah, and this is what is being done during execution. What else is happening? CI/CD is happening. Okay, CI/CD is happening. So all that is being deployed, all that is being sent to the server has to go through some kind of build, some kind of deployment pipeline. This is also coming from we are using some kind of Jenkins templates, not to redo it from the scratch on each and every application, but there are dedicated people that are really doing that. What else? Data. Data has to be taken care of. We have to check what was there in the on-premise. We are checking how to move it best. We are also checking different methods for data migration. So, I mean, generally you can either do simple backup and restore in the cloud, or you can use some kind of more elaborate solutions like data migration service, right? This is really cool, costs money, of course, but for some of the solutions, we are using that. What else? We are looking into the code and configuration. We are trying to optimize it. Maybe something is not really done properly. Maybe somebody hard-coded some password, right, in the code. We love that. So that has to be fixed. That has to be taken care of. What else? Configuration. So generally, we try to automate configuration. We try to automate installations. So if there is, I don't know, IIS, there has to be something that is, actually we're using Ansible Tower for that. Something has to install that. So that's web server, application server. Something has to do all the configuration. So this is what is also being created. And now we are moving the application to different place. So the integration has to be reviewed. The integration has to be modified. Maybe some of the integrations are moved to another integration solutions. That also has to happen. And this is happening here on execution phase. What else? Testing, of course. As in any IT project, you are doing the testing. And what we are doing, let's say, on top, we have this golden rule that the application, after it's moved to the cloud, cannot work slower than it was on premise, because it would create issues. It would create issues with users. I mean, generally, people like to not spend too much time waiting for the page to load, right? So we try to really make sure that this does not happen. The performance is not degraded. And that's not an easy thing, because imagine the situation. On premise, we have one single server. Some of them are really, on one single machine. There is an application server. There is a database on the same machine, right? Now you are moving all of that to the cloud. You are moving a database to RDS. You are moving the application maybe to some ECS, EKS, whatever. And now suddenly it's not on the same machine anymore. So making sure that the performance is at least the same is not that easy. So this is also happening. Of course, apart from integration testing, apart from UAT, this kind of things also needs to happen. Then security hardening, of course, we are moving generally to public cloud. Not all the applications are publicly available, but some of them are, even though we need to make sure that data does not leak by mistake. Okay, so security, work on the general security also needs to happen. Now, what comes next? The last, let's say, phase of the migration that we are doing is optimization phase. And optimization phase is already after the application has went through the UAT. There is a cutover, there is go live. There is another team, let's say, handling the operations for that app. So then another knowledge transfer has to happen. Also, there are some kind of bugs, right? Like in each software solution. So we need to correct those bugs. There has to be a new practices, new service management setup. Now your application is running in the cloud. So stuff is changing. You have different support team. You have different maintenance process. When you need to upgrade the things, this is generally different than it was on premise. So this thing also needs to be changed. We are doing performance tuning. So if there is a need of, or there is an option, also performance tuning is happening. Okay. What else? For some of the solutions that are really critical to the company, we have requirements to set up monitoring and alerting. Okay, so if there is anything happening bad with the application, the support team is instantly alerted about this fact, and they are doing some kind of fixes, even in the middle of the night. So that also has to happen, and that also has to be created, adjusted. Now, last thing, like, again, in any other project, of course, we are having users. Users are very creative. They would like to get some new stuff from time to time. So we are creating, basically, we are delivering new features. And also what is happening, in the cloud, you see very well how much does it cost. You're getting a monthly bill. So it's much easier to calculate it than in the previous model of having a server on premise. So there are also a work on the cost saving. And for example, what we did, very simple stuff generally, but if we are basically switching off instances during weekends and non-working hours on dev and QA, right? Production maybe not the best idea, but those non-production, this is very easy to enable and have that, and this really saves money. Okay, so that was it. And now let me go briefly to our recommendations. So this is our list, something that we did, most of them, and I hope this will help you as well. So first, do. So what you should do. First of all, I would highly recommend you to make sure that you do shape your teams properly, okay? If you would have a lack of skills, this will block you. You will be blocked in the implementation. You cannot go further because you have a guy missing, right? So make sure, just check before, what do you need, who do you need, and make sure you have that in the team. What else? Expect the unexpected, of course. Generally, plan with a buffer. For us, like a year ago, COVID happened, right? So nobody expected that. However, it happened, and half of the team was gone for 2 weeks, let's say, or 3 weeks, right? So all the go-lives had to be moved because we got the unexpected. What else? The last recommendation I would like to give you, at least for the do's, is to start early in definition of the patterns. This really helped us in order to get up to the speed of where we are now. So, of course, you can try to do migrations like each and every other project separately and so on and so on. But generally, the more effort you put on the beginning in definition of the standards, patterns, reusable blocks, modules, templates, whatever, this will save you lots of time in the end. Now, don't do that, because we did it and we were sorry. First one is that please do not underestimate analysis phase. This was actually some mistake we did on the first application we're migrating, and thanks to that we're migrating it for 12 months. Okay, this was great. Generally, we're finding out new databases every month, and this was a blocker for us. Generally, we had no idea what to do with that. We had to go back to the beginning, checking what that is. So I mean, and this was not that we were not super smart or something. But generally, cloud is giving you an option to really start fast, okay? You're going to AWS console, you're clicking 3 buttons, poof, you have a server, right? Then you're going to RDS, poof, you have database. So let's start, right? Why not? And this is the trap. This is the trap that we did, and really it is painful. Now, another one is that if you're doing migrations, try not to treat it as internal IT projects, okay? Why? I mean, there is a problem. That's if you start touching, let's say, applications that people are using, you are being seen as a guy that is breaking things down, okay? You have to pull those guys, you have to pull users on your side. You have to engage them early as much as possible, because otherwise they would resist. They would block you, they will not have time for you, and you need them. You need them to do proper testing, you need them to analyze the application properly. You really need those guys. So they should be in your team, not in the other team, okay? So try to have it as a general project, not IT project as such. Another one is about, it's more related to general people management and engineering team management. So you know that engineers like to work on new stuff, right? New cool tech. This is what we want to do all the time. But migrations are not always like that. So do not expect to always work on super cool tech. And this is a problem after 5th, 10th, 20th migration, okay? People start to do the same stuff, all and all again. How we handle that? We generally, of course, somebody has to do those repetitive stuff, but we moved those people who really wanted to do something else into proof of concepts, into defining patterns, into something that their skills could be actually useful. Okay, so this is how we handle that, and this is really, I think, good one. What else? This will be general. Do not cut down on testing. General for all IT, of course. I mean, you know that fixing something that is, find out on, UATs even are far simpler than fixing that on production, right? So as much as you can, try to test your solutions properly before launching it. this is my advice. And last but not least, do not stop learning. Generally, guys, cloud is evolving quite fast. Some pattern, some definition that you created in the beginning of the project may be already not up to date after a year. So you as an engineer, you as a developer, manager even, you have to stay on top because things are changing very fast. Something that was optimal 1 month, in 6 months, it can be really not optimal anymore. So this is the list of don'ts, but generally, this is what we went through and our kind recommendations. And with that, I would like to ask if there are any questions. Yes. Thank
you. Thank you. Actually, I have two. Sure. First is you, of course, had a lot of automation. But how many applications required more manual actions, so were out of schema?
You mean something that is going out of the rule, or?
Yeah, like you had to do something manual or migrate something manual because the application behaved in a wrong or unexpected way.
Okay, I mean, I'm not able to give you the exact number. However, I think it's not that big. Actually, with Ansible Tower, you can automate lots of stuff, lots of installations, lots of configuration. It's just a matter of knowing how to do that. So this is sometimes an issue for us. But of course, sometimes there is manual stuff to be done. But for this kind of cases, you can always go for Selenium or things like that. That is really doing manual things. But of course, it would happen. That's it, but not that much.
And the second one is, what about new applications that you are developing as a company? Are you adding those to those 600 cases, or you treat them in some other way?
Sure. Good question. So generally, we are not dealing with them at all. We deal with migrating of the applications from on-premise to the cloud. The new applications, there is a golden rule that you cannot get a server even in current on-premise locations. It's just blocked. You really need to have a great justification for having that. So out of the box, I mean, the only possibility you have is just to push it to the cloud. And this is the way to go from now on. Thank you.
Maybe I can answer partially the question, because for a new application, we are using the same platform which we are using for a migration of the applications. However, it works in different way, different approach. So either you are ordering the product and you have like your product team and you are follow the self-service standard and you are developing it yourself. But of course, you need to be approved. You need to go through all stages, architecture review, and we are checking if we already have similar application in the portfolio. If not, you have a like green light to proceed. Of course, you need to have a budget and so on. For like other cases, we are trying to look for like software as a service or something which is like can be globally used instead of developing something totally new and extend our portfolio.
Thank you, Piotr.
Thanks a lot, Patrick. Great presentation. I think you should write a book.
Oh yes.
After this, it's enough material for the book. One practical question on this quote slide. You were sharing like 3 security engineers, 3 architects, 6 like integration engineers, and then there was a test automation without number. So
okay, good question. So we do have one person that is actually overlooking the whole area, let's say.
One person, okay.
Yes, but the whole team is at least 10 people doing automation of the tests all the time. So they are, like I mentioned, they are benchmarking the performance of the application that is currently running on premise. And later they are checking how the same application runs in the cloud. And they are comparing those. So there is a whole team behind this.
Thanks a lot.
Sure.
And one more question, that one was too short. Just to dig deeper in this migration part with a new application part,
yes.
How do you align between new, let's say, new projects and migration projects in terms of architecture? How you do you have do you align the pattern so everyone invents their own?
Very good one. Thank you, Fedor. So yes, there is somebody, let's say, above us. There is architecture review board, and those guys are basically enterprise architects coming from different areas. And this is their job in order to make sure that we are following their, let's say, patterns, and anybody else in the company are doing the same. This is how it works. Thank you. Yes?
Yeah, before maybe going with the questions from the audience, we have a few questions, or at least one from YouTube channel. So maybe let's do it first. Question about the money. What are the most common saving options that worked for you?
Good one. Yes. So the most common saving option, like we said, is generally a switch off of those non-production environments when they are not needed. Also, we are using cost optimizer. This is a standard service in AWS, and this is really helpful. It tells you if your instance is just too big, or maybe you have too much memory, or maybe you have too much storage. So this is something that we try to follow after the application is already live. So after a few weeks of application running in the cloud, we are using those mechanisms in order to have some cost saving. That's it.
Thank you.
There was a question here.
So you said that you had close to 600 apps, yeah, to migrate. So how many of them did you end up replatforming? How many rehosting? How many refactoring? Like roughly percentage.
That's a good question. I think that's, I mean, we had this kind of rule that we should replatform at least 40% of the applications, right? This is, by replatform, I mean either changing of the database into open source, or changing, you know, the IaaS into ECS, you know, running the application, the container. But the minimum we have is 40%. This is to make sure that we are not moving as it is, because we would end up in a huge bill afterwards, right?
Yeah, that was my second question actually. So how is your business case holding up after the whole migration? Is it still as positive as in the beginning, or?
No, of course not. Of course not. So, I mean, I don't think that any IT project ends up in...
Stay in the light when you're saying that.
Yes.
You need to stay in the light.
So I'm not working directly on financials. I will not be able to give you the numbers, but it's always the case that that you are underestimating these kind of things. But the closer you are, the better, of course.
Yeah, of course. So I would say 60% roughly lift and shift is still quite significant. So yep. I'm guessing you're keeping a lot of the operating model from the on-premises, like the same monitoring tools, the same logging tools, security tool set, or are you actually retooling really the machines as well?
Not really. About, I mean, the services itself are changing. So we keep the applications as they are, some of them, of course, but the external services, most of them has actually changed. We started to use 𝐿K, we started to use Jenkins, we started to use AWS in general, AWS services. So this is changing, and that is allowing us to improve in the future as well, right? So this is the first step, let's say. Later, when we are checking that the costs are actually growing, we have to act upon it.
Sure. I have two more questions, but if there's anyone else that likes to ask anything, I'm happy to.
Short break, and I will come back to you. Do you have questions? Yes? Perfect.
Yeah, thanks. My name is Andrei, NX company. Actually, the previous guy stole one of my questions, so it's quite fair that I have the microphone before he asks the other two. Probably one of them would be also mine. I wanted to ask about the security in this whole journey. So you had these three guys, probably poor guys, on the screen, 3 out of 150, right? As I remember correctly, the team. What was their role? I mean, or what was the role of security team in the whole journey? Where they had their say, their word in all of this? You mentioned this centralized access rights and applications,
yep.
But apart from that, I don't know, did you do any penetration tests or application security, and so please elaborate on that.
Very good question, thank you for that. So generally, it wasn't just 3 guys. Those 3 guys were from, let's say, Experts Guild. They are fully dedicated to us. Apart from that, we have security guys in each squads, let's say, and they are dealing that on daily basis. And those guys that are in the Experts Guild, they are being used for, first of all, approving of the designs. This is super important. If there is something that is tricky, they are basically blocking it, right? If we have a huge issues, for example, with file shares, file FTPs, this kind of things, right? On premises, it was more or less safe to exchange files via SFTP. In the cloud, not really, right? So the main job of those guys is blocking this kind of great ideas and propose maybe something else instead of that. So apart from that, all the patterns that are being created, those guys have to approve it. They have to review it. They have to say what do they think about this, and if there are any changes, we have to apply to them. Thank you.
Okay, so that's me again. So again, 600 apps. How did you segment your target environment? Did you go the way, let's say, one big or multiple large shared accounts, shared VPCs, or did you micro-segment into, you know, like an account per app or an account per application bundle or something like this?
Another good question. Thank you. And this is somehow mixed with the security guys, because they are so smart to give us the recommendation, or actually make us to have a separate account for not even application, for each environment. This creates problems because sometimes it makes sense in order to migrate applications in clusters. Okay, they are integrated to each other, they are talking to each other all the time, so maybe it would make sense even to push it to one single account, right? But not in PMI. We cannot do it, at least for now. We do have this kind of separation between different applications. They are totally independent from each other. That's it.
Mm-hmm. And my last question. So you mentioned that at the beginning you had to invest quite a lot of time into the assessment, obviously. So how are you making sure that those mistakes are not done again? Like, how do you track after migration the state of your environment?
Yeah, very good one. We do have something that is called critical performance indexes. So we assess each and every application after it is migrated. So we do use some standard tooling like SonarQube. We use manual reviews. We use tools that are given us by the platform. And each and every application has to go through that process after the migration in order to make sure that a certain level of quality is being maintained.
So do you keep some sort of a CMDB, like a config management database of some sort? Or?
As well, yes, yes. But generally this is processed via Jira, to be honest. Of course, we do have CMDB where all the information is being stored, not in Jira. But for that purpose, this is generally a workflow, right? You're just moving tasks from one team to another. So Jira is perfect for that.
Thank you.
Thank you.
Thank you very much. And right now, questions from the void.
Yeah.
From the other side.
Yes, here.
Okay. Are you using Cloud Development Kit nowadays? Is there any hype for this service in your organization?
Yes, there is. However, we cannot use it. So, okay, going further. CDK is a very nice tool. This is based on CloudFormation. The thing is that we have Terraform Enterprise as an infrastructure platform. And of course, CDK can be now incorporated with Terraform. There is such a possibility. However, in the platform that we are using, CDK is not really an option. However, I know that in the company, some of the projects are using that thing, of course.
Great, thanks.
Thank you.
We have another one. When you plan to do a migration set of apps, how did you check dependencies? Did you use any tool to do inventory before?
It's another good one. Somebody has some kind of experience. So yes, we did use tools. I forgot the name of it. Sorry, it was like 2 or 3 years ago. But yes, we were using the tools that were actually, the output of those tools were you were installing agents on each and every server. And those tools were reporting to you which server is talking to which one. However, if you have a couple of thousands of servers, the mesh that you were receiving was enormous. Of course, we're getting some kind of a map. However, we couldn't really rely on it because it's not that easy to identify which of the requests are being made by the application and which are made by internal services of Windows or server, basically. So in most of the cases, currently, we are checking this manually. We are checking all the integration solutions that we have. We are contacting integration teams. And yeah, generally, we are doing this manually.
Great. Another one from the audience. It's, I think, about the AWS certification. So should anyone would to start in cloud industry, he should start with AWS Cloud Practitioner, or he can start in AWS Cloud Associate Architect?
Oh, good one, again. Depends, generally. So, I mean, it's up to you. I would highly recommend it to do the practitioner at least. However, you don't need to. The most important is that you get experience. And no certificate will really replace your experience, right? So good, let's say, strategy that I have is that in order to prepare for the certificate, you're actually learning stuff. You're learning the things that you do not have chance to experience yourself because your projects, your applications are not using certain services. So doing certification is also good. However, it will not replace you the real project experience. So I would start from the cloud practitioner, and later it's up to the specific person if certificates are actually making sense or not. I think on the market, by analyzing different CVs, many people that are in the cloud industry, they have it, architect, developer, or sysops. However, it's not a must, for sure. Thank you.
Okay, great. Thanks. Any questions from the audience? There is.
Yes.
Hi, thank you. Great presentation. I'm 𝐏𝐢𝐈.
Yep.
I do have a question regarding your journey in general. If you kind of use this journey also to you get to know all of these applications, hundreds of them. Have you used this opportunity to actually create some software bill of material that you will then map for the security-related operations later on?
Okay.
Like what kind of software dependencies you have, what kinds of libraries are used, what kind of frameworks are, those tools are used, because you actually were looking down into them. So you get this understanding now. Yep. Thank you.
Good one. Yes, we are having a platform. Sorry, but I forgot the name right now of it. I can come back to you later. But generally, yes, we do have a platform that is doing exactly what you just mentioned, where you have an application as an entity, and then you're mapping all the relations that the application has. We also register tech debts in that solution, just to make sure that we are working on that further in the future. But still, this is a domain of enterprise architects. Of course, we are feeding the information to them. However, we are not the owners of that process. That's why I'm not aware. Sorry. Any other question?
Oh, yeah. We have from the audience in the YouTube channel. So right now we have a question from Łukasz. You've got global presence. One cloud is enough. China, for example, are able to work in multi-cloud.
Yep. Good one. So this was a question that we asked ourselves when we were picking the provider. And we're not really sure. I mean, generally, we picked one in order to have the best deal, right? If you promise to a certain cloud provider that you will use only their services, they're much more willing in order to give you better pricing, right? This is, I think, public information. Sorry?
The voice from the audience, I see.
Yeah, you're getting basically discounts, right?
Yeah, discounts are good.
But you have to do some kind of promises. That's okay. We did. Still, this is why we, for example, didn't went into CDK or CloudFormation, but we went for Terraform. We are a tobacco company. Okay, there are risks related to having solutions branded by PMI. We are fully aware of it, and we are never sure if AWS will not kick us out, right? So we have to be prepared to be always ready to be moved to other clouds. Of course, it will be a challenge. However, for the solutions, for the services that we picked, they are, as you saw, they are not really AWS services, some of them, most of them actually, right? The auxiliary services we have, like Jenkins, Artifactory, Atlassian, those are not AWS services. And this was done on purpose, not to get another vendor lock-in, okay? So this was our intention from the beginning. If we are now to be moved to, I hope not, but if we would be moved to move to another cloud, it would be a huge challenge for us. However, you know, we need to have this kind of risks mapped and somehow at least be prepared to it.
Yeah, the new CTO will take care of it. No worries.
Let's see.
All right, perfect. So the last two questions. Do you have anybody on the audience here have a question? Good, because we have Eric still waiting with us on the other side. So the two questions from the audience from YouTube. Łukasz, again, it's going to be strong. Do you have some DevSecOps framework for dev teams?
DevSecOps framework.
Next question. Perfect. Łukasz, again.
Probably not.
Yeah, no worries there. Łukasz, again, do you use cloud native services tools from AWS? I think you reply for
yes.
that. Yeah.
No, generally, yes, we do, of course. I mean, those services are great. The thing is that we don't really want to rely only on AWS, right? So where it makes really a sense, we have chosen AWS services. However, not all. This is a nice balance between productivity and having everything in one basket and having some kind of universalism. So
yeah, thank you. Thank you very much.
Sure.
It was tons of questions. Thank you very much for that, for people here on site, the old on-premise business, and also the people from cloud. So thank you very much, guys, for everything. We do some short break because we don't want Eric to wait for us. Eric will talk about GitOps using AWS and full service serverless infrastructure. So it's going to be an interesting one. He's with us, but not visible right now. We will put him on the screen. I think it's a good time. So first of all, cheers for this lovely Piotr presentation. Come on, guys. Woo! Yeah, thank you very much.
Big applause. That was really cool and a lot of questions. So I'm really happy. So let's introduce our other guest today, Eric.
Eric, you look tired. Come on, you just wait, what, like 1 hour and a half? What is it, man? Eric, come on. Eric, good to see you, buddy. We wait for your presentation. I have some announcement, though. Here, down there, will go also the pool, and you can also, who are here, can take this pool and win some vouchers. So don't hesitate, just go for it. And Eric, I'm sorry to say that another pizza is coming soon. So you know the drill. I wish you to be here to taste it because it's a marvelous place that we take it from. But everybody here will enjoy it a little bit. So Eric, how many years you taking with the AWS? How much time you staying there?
2 years and a half.
Oh my God! It's always the day one, huh?
It's always day one, yeah.
Yeah, perfect. Good. Yeah,
we had a comment in the audience that it's still the introduction days. So.
Eric, good to see you. I think we can start, huh? Well, perfect. Okay. Already? Can you share? We will see if everything is visible here. We hear you well. Everything fine.
Okay, you should see my screen in a few seconds. Yes.
We see your history from Chrome. Sorry, no, the second one. I was just kidding. All right, guys, let's go. And let's give a stage for Eric. Thank you.
Okay. Hi, everyone. Okay, I don't see anyone anymore, but I will do it like this. So I'm Eric. I'm a solution architect for AWS. I'm based in Geneva, and I've been with AWS for 2 years and a half. And I recently joined the PMI account at the beginning of the year, and I'm working with other AWS people. And today we will talk about GitOps, because this is one of my favorite topic at the moment, and I will tell you why shortly after. You will have a mix of presentation, and I will show you a cool demo at the end. At least I will try to show you a cool demo at the end. But first, maybe a little bit of backstory. So very early in my career, 15 years ago now, so it's a lot, I created my own company, and we were creating a SaaS product for the pharmaceutical industry. And because we were a very small company, we had to innovate every day. So every day we had to release new features in production, correct some bugs, but mainly create innovation. Okay. And if you add on top of that the fact that we were working for the pharmaceutical industry, where it's a highly regulated industry and you have to produce tons of documentation, it was really hard to keep up. And the only thing which get us succeed was automating everything. So we were not talking about DevOps at this time, but we were really talking about automation, scripting everything that we can. So automation is really one of the key feature which is driving my work at AWS. At the same time, we were in 2007, 2008. We didn't have the cloud yet, and we had to deploy servers, application in our data centers. Okay, and it was costing a lot of money. So when we are talking about the hidden cost, you know, I can talk about this. Okay, what it's like to go in a data center with your rack, what it's like to pay for electricity, what it's like to pay for everything. So automation and cost are really the two things which are driving my work as a solution architect, and this is why I'm talking about GitOps today. And this is also what is driving PMI activity as well. As a solution architect, we talk about automating everything. You heard the talk of Piotr, and we also talk about cost. You ask a lot of questions about cost. So cost is a thing, and we really try to bring down cost every day. And when we look at the challenge today around automation, but also cost, the question really is, how do we release change in production? And how do we release change in production, not as a hero, but how do we release change in production reliably and continuously? Okay, how do I release change in production? It has to be the same every time, and it's reliable. So very often what we observe in big company is how to manage infrastructure at scale is complexity. You know, companies like PMI, it's highly complex, 2,000 application, and it's not the same. I've seen worst. Okay, a lot of companies today are drowning in complexity. If you add on top of that unclear role and responsibility, unclear strategy for knowledge sharing, and you see as well that you have a lot of manager who takes very high ownership because they want to deliver some really short-term goal. Then you know it creates silos. It creates silos in the organization, and you fail at knowledge sharing, and you drown in complexity. And the issue is really, how do I get rid of this complexity? And the first problem we try to resolve is consistency. Okay, where is my source of truth? How do I identify where is my source of truth? What are the changes that have been made? Okay, and how do I follow up with these changes? And how do I make sure that my changes are not, copied across all the organization all the time? You want a single source of truth. That's the problem number one, consistency. Problem number two is versioning. As soon as you as you start treating your infrastructure as a code, then you need versioning. You need to understand what is going on, who did what, who is taking responsibility for this change, and what do I need to do if I need to roll back those changes. So versioning is one of the key problem we try to resolve. And finally, automation. You want to make your deployment easy to automate, reproducible, and prompt to disaster recovery. So you really want to get rid of the manual deployment and go from scripted to fully automated environment deployment. Okay, so these are the three problems we're trying to solve, and GitOps is a great way to solve these problems. Okay, because first you have infrastructure as code, so one single source of truth for all your infrastructure. Okay. And it can be with anything. I will demo CDK today, but you can use Terraform, you can use Ansible, you can use many solutions, as long as you treat your infrastructure as code. Git is a great solution for versioning. Okay, it has proven to be the best solution among all the versioning solution out there. And finally, CI/CD to automate everything which is related to build, test, and deployment. So GitOps is a single source of truth to deploy the whole stack. It's a single workflow. The cool thing about GitOps is that, and with AWS, is that it can also roll back all the deployments you are doing automatically. Okay, and maybe we will talk about observability later, but observability is one of the key topic in GitOps. Infrastructure as code. Infrastructure is defined, built, and run through CI/CD. And again, we were discussing before with 𝐏𝐢𝐻 with multi-account environment. So when you want to manage multi-account environment in AWS and you want to deploy reliably in each of these accounts, you can only do that through CI/CD, through a CI/CD pipeline. And then drift detection, you want to detect when there is a drift in production. And what we observe at AWS is that when you enforce this DevOps practice, teams are usually 3 times more effective. They restore service after accident in less than a day in 77% of teams, and vulnerabilities are remediated in less than a day in 60% of the teams, because you are in control of your environment and you are in control of what is going on in your environment. So provisioning and managing infrastructure as code, you have to code your infrastructure, and we will see it with a CDK. You commit to Git, and as soon as you commit into Git, it triggers the CI/CD pipeline. Okay, and what the CI/CD pipeline is doing is taking your CDK code, in this case, and transform it in a CloudFormation code. Okay, so at the end of the day, it's you code in CDK using an imperative language, but what you get at the end is a declarative language. Okay, so your CDK produce a CloudFormation which is deployed in your environment. And these are the GitOps stack. So today I will show you AWS code commit, of course, CDK, CloudFormation, code build, code pipeline. But you can use the same philosophy and the same approach with many other tools. At PMI, they are using Atlassian, but you can use all of these tools: Terraform, Atlassian, CircleCI, GitHub. Okay, so really, it's not just about a specific product or service. It's about having the right philosophy and the right approach. And of course, CDK is really an accelerator for the teams. CDK is an imperative language which is translated in a declarative language, CloudFormation, and it's supported by many languages. You can write CDK in JavaScript, TypeScript, Java, C#, Go, and we just released in reInvent Rust and Swift. So you can really write your infrastructure in many, many languages. Today, I will show you an infrastructure in TypeScript. Okay. So this is the part of the automation. Now I want to discuss about a real world requirement. This is a demo that we will do today. Okay. And so this demo, what is it? It's if I look at my requirements, it's a 3-tier web application. So web application, very, very standard. I want it to be aligned with the well-architected framework that we have in AWS. I want my application to be simple and lightweight, based on container and serverless when possible. So let me unfold all of this. When we talk about a standard AWS architecture, you have a kind of blueprint on the left of the screen. This is usually when we are talking about an AWS architecture. So for the people who don't know, or for the people who are not quite familiar with AWS, when we are talking about a region in AWS, we actually talk about 3 different availability zones at least. It means 3, you can see an availability zone as a group of data centers. So when you are actually building an AWS, you are building your application to be available across multiple data centers. And these data centers are close enough to offer a millisecond latency. So you can build synchronous application while being available on multiple data centers. And this is really cool because for the people here, architects who have built asynchronous application, you know how hard it is to achieve consistency and with asynchronous application. So this is what I call a standard AWS architecture. We want it to be aligned with the well-architected framework. So there was a question earlier on this certification. Should I go with the cloud practitioner? Should I go with the AWS Solution Architect Associate? If you go with the AWS Solution Architect Associate, you will learn what the well-architected framework is. And I would really recommend any architect, even the one who are not architecting on AWS, to get this certification, because it really provides you a good way to think about what is a well-architecture, okay? And when we talk about the well-architected framework in AWS, we are talking about 5 pillars, which are security, reliability, performance, cost, and governance or DevOps, okay? So these are our 5 pillars, and what we want to achieve by deploying this application today is to have a good balance between these 5 pillars, okay? And the last thing I want to unfold, I say serverless when possible. And when we talk about serverless in AWS, people always think Lambda. Beam, you're doing serverless, I'm doing Lambda. It's not always the case, okay? Yeah, in AWS today, we have many applications which are serverless, okay? And it means that we abstract to our user, to our customers, storage, and compute. So as a customer, you don't have to manage your compute. You don't have to manage the underlying nodes. You don't have to manage your CPU, your memory. You just say, I want to run a workload without having to manage my server, my nodes, my CPU. Okay, so these are my basic requirements. And I want to run a container because we like containers. Containers is a really nice way to deploy lightweight application, highly standardized. Okay, so we have different offers in AWS to deploy containers. We have ECS, we have EKS, which is our Kubernetes service, ECS, which is our container service. This is our own way of deploying containers in AWS. And you can run both this service on either EC2s, where you manage your underlying nodes, your CPU, your memory, or you can deploy these services on Fargate and you let AWS manage only what you need and you pay for only what you consume. Okay, so I go with ECS, and because ECS is really well integrated with AWS. If you are into AWS, this is the most natural way of running a container. And I'm not saying EKS is not cool. I love Kubernetes, guys, but for the sake of this demo, I will run ECS. Okay, so ECS is really AWS opinionated way to run containers at scale in an AWS environment. And how does it work? Well, you usually have your container instance. Okay, this is really the containers you are building with Docker or with other solution. And these containers, they are running in a task. Okay, so you can see a task like a pod in Kubernetes. So you have a task definition where you instruct ECS how to manage the container which are in the task. How much CPU, how much memory, what kind of images you want to use, how you manage logging, how you manage security, how do you attach storage, how do you scale, and how do you react to load, okay? And then you have a service which is monitoring what is going on and maintain the right number of tasks, the desired number of tasks as instructed by the task, okay? And it integrates with an elastic load balancer, and you will see exactly how it works just after that. And the task definition is a JSON. So you know that in AWS, everything is driven by an API. So everything is API and everything is driven by JSON. But because we are using CDK, we have a much higher level of abstraction to define our task. And we will get into the code really shortly. Fargate is our way of running application of choice, because I said that I wanted to use serverless. Okay, so with Fargate, I don't need to care about the underlying nodes. I don't need to care about memory. I don't need to care about CPU. I'm just asking AWS to manage EC2 instances for me, the instance on which my container will run. Okay. Yes, and you only pay for what you use in Fargate, which is really cool, because if you have a container sleeping somewhere and no one is using it, you are not paying for it, even if it's running. So if we look at how Amazon ECS looks with Fargate, this is the same architecture that we wanted previously, but now you see that in the middle, we have this ECS cluster which is running with a service definition, task definition, and Amazon ECR, which is our container registry. In this demo, I won't instantiate any database, okay? And of course, because I want to achieve a zero trust architecture, I have different level of security which are applied. Okay, I have a network level architecture where I segment my my network in different subnets, and I have other security measure as well with roles, IAM roles, policies, web application firewall, etc., etc. And finally, what I will do, I will deploy 2 pipelines. Okay. The first pipeline will be in charge of my infrastructure. Okay. So the first pipeline will deploy my cluster, my storage, my networking configuration, my VPC. So that will be my first pipeline. My second pipeline will be in charge only to deploy my application. Okay, this is the pipeline that will be in charge of building the container and deploying the container to the registry. Okay, so I have chosen to have 2 different pipelines because I have different life cycles, different teams, different roles and responsibilities, etc., etc. So I separate infrastructure and application code. Okay, and it's really up to you. How do you want to manage your pipeline? How many pipelines do you want in a GitOps approach? Okay, there's no rules. Okay, but maybe you will have some follow-up question after that. But I've made the choice to have 2 pipelines. And if we look at the final architecture, so we have this well-architected approach with 2 availability zones, 1 cluster being highly available across multiple data centers, subnetting, load balancer, and we have these 2 pipelines at the bottom that will deploy my infrastructure and my my application. Okay, so with that in mind, I will now move to something which is more tangible. I will move to the demo, and we will look how it looks like in the demo. So let me stop sharing this, and I will start sharing my code. No, it's not this that I want to share. So I hope, okay. So this is some CDK, okay? And I won't get into every details of the CDK, but there are things that I want to show. For example, the first thing I do, I deploy a VPC. And I deploy a VPC with my 3 subnets: public subnet, private subnet, and secret subnet, where my database will be hosted. Okay. I ask for 1 NAT gateway for the private subnet, but not the secret subnet. And because I'm still worrying about the cost, I don't want to use a standard NAT gateway of AWS because for me, it's a bit too expensive for my need. So I decide to instantiate a very small instance, a T3A Nano, which costs me $3 a month, and which is good enough for my need, okay? And you can see that in literally 10 lines of code, I start deploying a very complex VPC with NAT gateway across multiple availability zones. If you want to do that manually in the console, it will literally take you 30 minutes, at least if you know what you're doing. If you're a solution architect and you know what you're doing, it will take you 30 minutes. And you need to be very awake, okay? Because it can get really complicated really fast, okay? And then I deploy security group, my cluster right here, my task with all the policy statements, because again, I don't want to have open policy to the world when I say, hey, please let my task run everything. No, I'm in a zero trust mode. Security is my pillar, so I want to deploy advanced policy. Okay. I define my task, my container, which is in a repo, which I have indicated. Okay. My target service, blah blah blah. Okay. I don't want to get into all the details. You have the idea. Okay. This stack will compile in CloudFormation and will be deployed by GitLab. Okay. And by the way, what I've done, this is also important. I also deploy my CI/CD pipeline for the application. Okay. So where do I get my my Git repository, my build command, my post build command, how I deploy my application, etc., etc. So this infrastructure also deploy the CI/CD pipeline of my application. Okay. And this is where I create my pipeline, still with policies. Okay. And I tag everything because you need to tag in AWS if you want to understand what is going on in your application, especially from a cost perspective. Use tags. It's cheap. It's a cool way really to segment and understand what you do. And then my application has deployed a load balancer. I want something which is more expressive. I want to put a domain name on top of my load balancer. So I will show you that just by commenting this block, I will deploy a SSL listener linked to a certificate which points to a zone name, which is demo.bianchi.io. Okay, and I will commit it here. Okay, so git commit, and I will push later. Okay, now I want to share another screen. So not this one. Yes, this is the one I want to share. So this is my application, okay? And you will see in the application, I will show you just after that I'm saying hello Krakow somewhere. Let me find it. Yes, hello Krakow, and I have 2 stars here, and I will remove the 2 stars. Okay, and again, committing, removing stars, I'm committing, and I will push later. And now let's go in the browser and see really what is happening in the browser. Okay, so this is it. I'm in my account. So let's go and see what is going on. So I have this application here. This is a load balancer. And if you look at this application, it's here and it says, hello Krakow, 2 stars. And I can reload it. You can see it's live. Okay. Let's go and see what is going on in ECS. Okay, so if I go and check what is going on in ECS, I have my cluster here. Okay, with my service, and my service is managing the task. And my task is here and it's running. Okay, and I ask ECS to only run 1 task. Here, it's actually running 8 tasks. Why? Because I'm currently flooding this application. Okay, you can see it here. And I'm flooding this application with hundreds of requests per second. Okay, something like 500 requests per second. Okay, so the application is scaling out, so scaling in. So I have 8 containers running across the 3 availability zone in Frankfurt. So 3 different data centers in Frankfurt. It's all transparent to me, okay? And it could be a major event because, I mean, I have hundreds of requests to handle, but it's not a major event for us because we are running on AWS, we are well architected, and we are using GitOps. So while we are taking all this load from customers who are connecting on this application, what we're going to do, we're just going to deploy new changes in production. Okay, so let me push in production. So let's go and see code pipeline. So here are my 2 pipelines. The first one. Oh, damn. So I will push in production. Why doesn't it work? Oh, damn. Okay, this is the demo effect. It was running yesterday. It does not work today. Why? Let me. It's crazy. Okay. It's not working. What I can do, I can trigger this pipeline manually. Okay. So yes, it's really bad, really stupid. I'm sorry, it doesn't work. This is really too stupid. Okay, I will start the build and you will see how it looks like.
No worry here, man. We're waiting. You can do it manually.
Yeah, I'm doing it manually, but it won't be the same. It's really stupid. I tested it few hours ago, and it was working.
Don't worry, we all had here that, you know, the demo goats are like this, so no worries.
So what is supposed to happen? Okay, as soon as I push into the code, you see this 2 pipeline running, and what these pipeline are doing, okay, they are detecting that there is a change in code commit. They start doing the build, and when I say build, it means that it can run test, it can run some sonar check, it can deploy build the actual Docker file, deploy initr, and you can add as many steps as you need. Okay, and you can even add manual step if you don't want to go directly in production. Okay, because maybe you want your team to deploy their application in production directly, but maybe you want to look at what is going on when you deploy your infrastructure. Okay, and then once the build is done and the image is actually deployed in ECR, then what you see here in ECS the really cool thing here about ECS is that ECS is doing for you a rolling update. So you have 8 tasks running because this is the number of tasks that we need to handle the load. And ECS will start to spawn new tasks, 8 new tasks, okay? And little by little, the load balancer will send the traffic to the new task and remove the old task. So in the middle of a major event, and if your Git client is configured correctly, and I don't know why it's not working, you just push and release in production application code and infrastructure, and it's completely transparent for your user. Okay, and this is really the cool thing. And with AWS, you only pay for what you use. It means that you pay for when your pipeline is running, and you pay for when your tasks are running. So here, for example, I pay for all this load that I'm taking currently on AWS. But once the load is over, I'm just paying for the small amount of CPU I'm using and the small amount of money I am using. And I'm getting back to my slide. This was a demo. And you can find, the really cool thing is that you can find this demo on my GitHub repository. So if you don't believe me, you can get the demo from GitHub and run it in your own AWS account.
Okay, thank you, Eric, for a presentation. Audience here, any questions? Too much beer, I see. Any questions for Eric? All right, online, do we have any questions? No questions. Eric, thank you very much for a presentation. I think we will come back to this subject because CDK is always coming back to us, I think, recently. At last 2 meetings, we talk about it all the time, and serverless is always with us. So, the most pleasant part? All right, good. I will take this microphone. Yeah, okay. Thanks. Everybody, wait for that. Yeah, so there were 2 guys. The guy who had millions of questions.
They already left and
they get the bug. Okay,
but
this guy
they
did it back.
took the bug. Yes,
took the bug. Okay, because this part of it's so online. If it's still with us, Łukasz, congratulations! Please give a shout on the YouTube channel. You will get the package for the questions. They were tricky. They were bad. They was exactly what we need.
Exactly.
Yeah, and one more. So, of course, thank you very much for your questions. It was a pleasure to hear you. Yep. And another, and do we have anybody here to ask the questions? You move, guys, you move. Oh my God, it's so bad. Who? You show me now. Yeah, type
who asked the question?
Yeah, I think so. This person, yeah. You just watch your phone like nothing is happening. You know, it's a good question. You think that you will go home, without nothing from here? Come on, man, cheer up a little bit, guys. Thank you very much for that. We have 3 people who get the vouchers. We will contact with them. The first 3 who reply the questions. Maria, should we read them loud?
Do you have already the results?
Yeah, the 3 people that get vouchers. Should we get them here? Yeah. So, so first of all, it's gonna be Aborucki, Wozik, and 𝐿ę𝐝𝐳𝐢𝐜 Jakub. So these 3 people will contact you guys. You will get your vouchers. Remember, there are vouchers for AWS, not Amazon. Yeah, you tricky bastards. For sure, you want to buy some stuff. So thank you very much. The next meeting. Oh my God, where is going to be next meeting? Maria, where is going to be the next meeting? When we will have it? Soon. I love it. It depends, guys. Enjoy your time here. Thank you, Eric, again. I hope next time you will be here because Kraków have many faces and can lead you in many ways. And I hope today we will be somewhere there. It's Monday. Come on, guys. You know, so it's like a perfect day. It's like a small Saturday. So let's start the evening. Thank you very much. Next meeting is gonna be soon. Thanks. Thank you very much. And
thanks a lot,
cheers for Eric.
Thank you.
Yeah. Thanks.
Enjoy the night.
And remember, guys, if you want to be on this scene, just contact us. You can find me on Twitter, Maciej Lelusz. You can find us through Meetup website. If you want to present something, it ought to be 45 minutes on 1 hour presentation. It can be live learning talks. If you have any experience, good or bad, or even better, to share with the community, to not make them to make the same mistakes. Okay, this is the best one. If you can do it, the stage is open. And you can be here. We can have a dry run. We can help you guys. So be open. This stage open many careers. So good to hear you again. Thank you very much again. Bye.
Thanks.